good to be on one wave, and we also big fanats of real time.
I can see that.
Thank you. Okay, Vista. So maybe you now relocate to Alexander.
Alexander Tsarev, are you ready to start with supply chain?
Switch the presenter to me.
Yes, let's change that and please start whenever ready.
Nico, tell me when you see my screen.
I can see it now.
I can see it, yes.
Perfect.
Okay, good. Nico, as I understand, Rista actually showed you before the system itself, so you probably know some basics. Is it right?
Yeah, very briefly.
Okay, then I will not go too much into the details of the user interface, but I will try to focus on the use cases we have for this system. So this is the supply chain management system, more precisely supply network, because we deal with networks primarily. And the example you see on the screen now is the Coca-Cola in Germany. So we developed and deployed the system for the Germany. Here in this network, they have about 300 distribution centers where the production should be, the products should be delivered from the factories. And they have about 10 factories in Germany altogether. They produce different types of products. Some of them, some of the factories have the same technological processes. Some of the factories produce unique products. So in this case, the goal of the system is to help people to satisfy all the orders from the clients. The clients are big shops in this case, so they have their own distribution centers, and our goal here is to tell the guys in Coca-Cola what, when, and how should be developed, which products. As input data, we get the stock levels, which products we have at specific storages, and we have orders as input data, and also existing production and transportation schedules, which are somehow accepted already. And on top of this, the system schedules how the additional orders should be implemented. What should be produced additionally, what should be delivered when, and so on. On the map, you can see where the orders are implemented well and where we have potential problems. The green color shows us that the orders in this part of the network are implemented well. If you zoom in to the map, it will show you more details, because on the top level it is just grouped, and each circle on the map shows you several distribution centers or factories together. If you zoom in, you can see them separately, like this. So in this case, you can see already some specific distribution centers. You can check what happens at specific distribution center. Besides the map, you can see also charts on the screen where you can see the activity in your network in time. You can see production here, you can see locations here. The higher the bar is on the chart, the more products are produced or relocated in your network at specific interval of time. It can be daily, it can be hourly, it is up to you. You can choose what to show on the chart actually. So the main result in this case is to show the people who are responsible for the orders implementation, to show them which orders need some specific attention. In this example, we have altogether we have about 1,000 orders in the system. I can see it on the left at the bottom of the screen. We have some indicators here, and one of them is the total number of orders. I can just show you the names. So the total number of orders. Then you can see shifted orders, and this is actually the table I just opened. Here in this table, you can see all the orders which are delivered from the factory, which is not preferred by the final customer. When the customer places the order via SAP, it says which factory should deliver this order. But in real situation, the system may just propose to change the factory because it is more profitable to deliver it from another one. Like in this case, in the first line, that the customer expected the order to be delivered from Dorsten, but the system proposes to deliver it from Knetzgau. Just as an example, in this specific order, we have 3 different products, and actually, as a reaction to this proposal, the user can either accept it and just change the order to the proposed factory, or the user can fix the preferred factory, so to force the system to schedule from Dorsten in this case. So if you do this, the system will start some rescheduling, and as a result, you will just get the same order scheduled from Dorsten instead of Knetzgau as system proposes now. I will just show you what will happen in this case. When the system reschedules it, the order disappears from this specific list just because this list shows you shifted orders. If it is fixed, it is not shifted anymore. It will just go to another list. I will just find I will find this order by the number in the list of the full list of the orders. Okay, let's just check. Okay, it disappears from this list. Now I will just open the complete list of the orders. And I will find it by the number. Here is the result of rescheduling, actually. Here you can see that now this order is actually delivered from Dorsten as customer preferred, but we have another problem now. It is now delayed. The preferred time was 21st of August, but the system tells us that this order can be delivered only on 22nd of August. And it also shows you which product causes this delay. There is a sign of anchor at the specific product in the order, this one, and it tells us that this product causes the delay of the whole order. You can click here and see what happens actually with this specific order in the network. And see, you can see that there is actually a fixed transportation, which is already accepted, and it is probably started already from Dorsten to Knetzgau. So it means that this order, this product goes out of the Dorsten to Knetzgau, and in order to deliver the complete order from Knetzgau to the client, we have to put it back, to transport it back. So we have this transportation operation here, which costs us additional 167 euros for this specific product, because we have to deliver it back to Dorsten to deliver from it. This is actually shows you why the system proposed us to deliver the order from Knetzgau before we fixed it, because it is more profitable to do it. It doesn't make sense to deliver this product back because we have all the same, all other products at Knetzgau. We can just deliver it from there. This was the example. Besides the shifted orders, again, we have 14 postponed, delayed orders where the date is different. So you have preferred date here, and we have the date proposed by the system. This normally happens when we don't have enough time to produce something or to deliver something in the network. This stuff can also be discussed with the clients, and if the client agrees, the order can be shifted I mean delayed in time, the date can be changed, or they can change the contents of the order and deliver something later, some separate products. And there is also a list of the orders where we have specific products which cannot be delivered at all. Like this order, out of 10 positions, sorry. Out of 10 positions here, you have one which cannot be delivered in our network at all. This is probably because this specific product is not produced in Germany, and it should be in stock. If it is not in stock, the system is not able to deliver it. These situations also should be somehow solved by the staff. Besides the people who work with the orders, there are also users who are responsible for production, and they work with the list of proposed production operations. Here in this list, the system shows what should be produced additionally to the accepted production plans in order to implement the delivery of all the orders as it is shown now in the system. So this table, it shows you the name of the factory, the quantity, and the name of the product which should be produced, and the date when it should be produced. And the people who are responsible for production, they can either accept the specific line from here and put it into the accepted production plans. Then this position will go off this list to the list of the pre-planned production, or they can introduce the specific limitations. They can tell the system that the specific plant cannot produce this product at specific day for some reason, because of the plant capacity or the lack of materials or whatever. Actually, the system in this case, when it plans the production, it considers also the availability of input materials and the technological processes. But in some cases, of course, there are limitations that are out of the system control. And the same type of table we have for people who are responsible for transportation. Here we have proposed transportations, and the principle here is the same. You can see the factory, the source factory and destination factory for the products that should be relocated, and the quantity and the name of the product, and the date, of course. The same stuff. If it is accepted by the transportation department, this line can be put into the relocation plans, transportation plans. Otherwise, they can introduce the limitation. So this is in brief about the Coke case. If you have any questions, you can ask.
Just 2 words to a little bit explain the task which we're trying to solve. So they have 5 factories, 300 storages, and about 1,000 shops, which in 10 days horizon every day change their orders, saying, I need 3 pallets of cola, I need 2 pallets of mineral water extra, I don't need some Sprite, but I order some Sprite, but I see that we don't sell it. And so continuously these plans, these orders changing, and you need dynamically to rebalance all resources inside your network. Is it clear, this very simple main idea?
Yes, I can see that.
Okay, great.
And Miko, I can also show absolutely another case for the system where you can see how you can change the network itself and model different network layouts. In this case, we actually model the electricity supply in California, and here you have a more or less simple network where you have several cities with the energy consumption, and you have several electric plants in California. And the system in this case schedules how to supply the electricity, where to take it, from which factory, and which channels to use in order to deliver it to the final customers, to the final users of the electricity. And it just, this case just shows you how you can work with the network in the user interface. For example, here I have the plant which is called James B. Black. You can take it, and you have also Sacramento here, which is not supplied at the moment. You can use user interface to deliver, to create new channel and to deliver the electricity like this. So then when I add the channel in the user interface, the system automatically reschedules the electricity supply, and you can see immediately how the flow changes. You can see now the blue line, which shows you that electricity goes from the factory to Sacramento. But this plant is quite small. It cannot supply the full consumption demand at Sacramento. So I can also use this one to supply. So I create a new channel, and the system again reschedules automatically, and you can see that in this case it just shows you that this plant is actually enough to supply the complete demand to Sacramento, and the previous plant is not needed anymore. So you can see that this channel is white, there is no flow here, but the new channel is used and this factory is used. I can further let the system to deliver the excessive power to the rest of the network. I just create channel to this group of cities like this. And you can immediately see how the demand is satisfied. And all the power now is taken from the factories, and you can see where in your network you have a lack of power supply immediately. So this just shows you how to work with the model interactively and try different layouts of the supply chains. Is it clear?
Yes, it is.
Good. So the guys actually says that we are run out of time. I could show you a couple of other cases where the system can be used, because we use it actually for absolutely different types of supply scheduling. Like we schedule, for example, the supply of wagons in order to deliver coal from the mines, or we use it for building structures to schedule the delivery of the building materials. And in all cases, in different cases, different functionality, functional parts of the system can be used. Somewhere it is more like production, somewhere it is complex network, somewhere it is complex rule from the channels,
Very interesting.
Okay, good. If we stick to the agenda, I guess Lada should continue, right?
Yes, please. Thank you.
Thank you.